Welcome back to ESG Decoded. This is Amanda Hsieh, and today I have with me Rick Wenger from Skyven. Rick, how are you?
I'm well. How about you, Amanda?
I'm doing good. Thank you so much for making the time to join me on the podcast today and talk about decarbonization with a focus on process heat, which we'll explain to everyone, or you'll explain to everyone. But please tell our listeners a little bit about Skyven and what you do there.
Yeah, absolutely. So, Skyven Technologies, we're a energy as a service company, which I know we'll also get to a little bit later. But,
Yeah.
Essentially what I'm in sales. I'm a mechanical engineer by degree, but as you will find out here, I talk too much. And so they put me in the sales department. And what Skyven does is it's a really cool company. We work with customers to, specifically large manufacturers, to help them reduce their CO2 emissions. So we really do that in a few ways. The first being we identify large opportunities for CO2 emissions reduction. When we say large opportunities, we're talking 20, 30% or more, hopefully up to 99 or 100% if it's possible, and everyone has the appetite for it. And we help do that, economically. The other thing we do, we manage and take full responsibility for installing the systems, including all the way through maintenance of the system. And we are in the vein of an energy as a service company. We align our financial goals with our customers' CO2 emissions reduction. And what that means is that we literally install meters on the equipment and measure how much clean thermal energy it's delivering, and we charge based on that.
So I remember the Skyven, there's a big focus on process heat and really focusing there. So tell our listeners who aren't familiar, what is process heat?
No, and that's a great question. It's something we get a lot. And so almost everywhere you go, there's heat required for different things. So, in your house, there's a furnace and it heats up your house, right? That's pretty obvious. But for basically every product that you touch, heat is required to make it in one way or another. So if it's a plastic, you require heat to make the mold. For your food, you can imagine it's just like cooking in your house, except on a much, much larger scale if you're making hundreds of thousands of pounds of cheese or butter a day. And so heat goes into that, right? And that's when we talk about process heat, it's from a large manufacturer.
I think of, a long time ago, I was a supply chain auditor, and I think about the textile finishing factories that I audited, and they had these essentially huge dryers. I remember visiting, auditing a paper mill. And I also remember just a lot of furniture that was painted, depending on what paint they used. Sometimes there would be these huge, I'll call them ovens, where the products would go through to cure, basically. Would those also be examples of process heat?
Those are fantastic examples of process heat. That's exactly right. It's one of those things I have two little kids, and I always tell them, like, the scale of human consumption is like beyond what you can imagine. So like the places you went, Amanda, I'm sure like the amount of paper you saw at a paper mill, and
that was
the
cool.
amount of paint, it's unbelievable.
It was also kind of cool to see potato chips and French fries being made. So I also, like you said, it's like cooking at home, but multiply it and scale it up multiple times.
Yeah. And it is truly unbelievable. And I mean, when I say everything you touch, like when you get into your car, the paint on your car has been dried. Like there's huge dryers with like car after car after car going through, and that's really what process heat is. It's anything to make a product that requires heat, and basically anything you touch, anything you consume, including the packaging. You get a box from Amazon that was made with process heat. And
what I remember is that heating up these ovens or kilns or whatever you want to call them, it takes a huge amount of energy, and whether that's electricity or a natural gas, as a fuel, whatever it is, it takes a lot of energy.
Yeah, that's exactly right. And there are these. I used to work at a burner company as well, and we used to make a burner that was 16 feet tall. So there's pictures of people inside of them, right? And those go into like some of the wood kilns and things like that. But it's the amount of energy is unbelievable, whether it's electricity, whether it's a fuel, natural gas, RNG, whatever it may be, right? And I think what's really interesting about process heat, so electricity, you put electricity in, right? And it comes out typically as mechanical motion or light. That's how the electricity is used. With thermal energy is really interesting because you put thermal energy in and it comes out as thermal energy, but it's at a lower quality typically. So you can imagine, like, if you bake a pie in your oven, right? The energy from that is either going out, it's being exhausted, or it's going into your pie. And when you pull your pie out, you can't like take that heat back from your pie and make another pie with that heat exactly. And so like the real trick with thermal energy is like figuring out how to use lower quality, even though it's the same amount of energy, it's like lower temperature. And so like figuring out how to take that lower temperature energy and kind of like boost it back up and make it usable. So you use less heat to boost it back up, or less energy to boost it back up.
I think about what I'm thinking about is basically how do you save that? Maybe it's not hot air, but it's a warm air now. And how do it's still warmer than ambient, and it took energy to make it that warm, I guess. So let's not waste it. Is that a good kind of way of thinking about it?
Yeah, that's exactly how you think about it. And there's a whole bunch of ways to do that. And it's interesting. There's a lot of ways that heat is exhausted or extracted. So I think a really good thing to think about with this is when you're driving down the interstate and you go by a plant, a big industrial manufacturing plant. Most times you don't know what it is, but you see this huge plume coming off the top of it. That's not like terrible emissions coming out. The emissions you actually can't see normally out of the exhaust stacks, but that plume is steam coming off. And so a lot of the ways that they get heat out of there is they use water or a liquid to pull the heat off, and then they exhaust that to atmosphere one way or another. And so like recovering energy from that, lower temperature liquid is a way you can do it with boilers and things like that, or exhaust heat recovery like you're talking about, and just literally putting that hot air back into a burner or a process. So there's a lot of different ways that things can be done to use less natural gas, use less as a fuel to make the same products with the same temperatures, with the same quality.
And that's where Skyven comes in, right? With those solutions, exactly. With that analysis.
Yeah, that's exactly right. We always say there's a heat source, and a heat source is pretty obvious where it's at. Like you walk through these facilities, you see the huge burners, right? There's a heat sink, and those can be a little bit less obvious. In a boiler that's like feed water coming into it, or, in a burner, like we talked, you could preheat the combustion air. But trying to create the connection between the heat source and the heat sink, and then trying to boost up the temperature so it's usable again, that's like the real trick in it. That's kind of the art and science of it. And that's what we consider ourselves experts in.
Nice. And then you mentioned the term energy as a service. So you have to explain how that connects with all this.
Yeah, no, absolutely. So, there's a whole bunch of different business models, right, on how energy is delivered. The one I'm sure everyone is most familiar with is you just literally buy energy from your gas or electric supplier.
Yeah.
And, large corporations do the exact same thing as we do at our house, just on a much different scale. And so what energy as a service is it is a business model where customers pay for essentially an energy service without having to make upfront capital investment. So let me give you an example. Mm-hmm. A customer has a boiler right now, and they are using that boiler to make steam. And so specifically, if you're going to do energy as a service in the sustainability world, which is what we do, we would propose, say, a heat pump that would create steam at the same temperature and pressure. Skyven will install this piece of equipment to offset all your boiler use. So we'll install this piece of equipment for you. You don't pay anything. What you pay, though, is we put a monitor on the back end, or someone else would. Anybody who's an energy as a service company, And they charge based on the energy that's produced from that system. And so you can imagine it's very similar to a utility in the sense that the energy created from that system is measured in BTUs or kilowatts if it's electricity. And that's how they charge. And they charge for the length of a contract. So it's a really good way for, for anybody, for large manufacturers, specifically for large, commercial customers as well, to be able to put a piece of equipment in with no upfront capital and pay over, the life of a contract where, it's nice to be able to sometimes like jump those capital cycles and get projects done that sometimes you can't otherwise get done.
I think it's really interesting because, like you said, sometimes it's that capital, that jump you have to make to invest that capital up front. And with the energy as a service, it helps to kind of eliminate that barrier. With having this on-site, may I say on-site generation, is it more resilient? I'm just thinking about, I live in Texas. 2 years ago, we had this very famous winter storm come through, and that knocked out a lot of our energy, our electricity grid at least, for a painfully a long time. Probably just a few days, but it was a painful few days. Is it more resilient? Is it to have these sources of energy generation on site essentially?
Yeah, so I think energy generation is a bit of a loaded term. It means a lot of different things. So specifically for Skyven, we're not, in a way we generate energy, but really we're using, like, let's say, electrical energy to generate thermal energy.
Okay.
There are energy as a service providers who would install like a natural gas turbine to make electrical energy that could be more resilient. It functions similar to like a generator, natural gas generator. So I think I'm sure there are companies that offer energy as a service in terms of like resilient energy. Kind of in the clean tech space, it's a little bit different what we're doing. It's in some cases it can be more resilient. There are things like thermal storage. There are things like, potentially renewable fuels and solar thermal and things like that, where I think you could probably make the argument that it is more resilient. But as a whole, I wouldn't classify it that way. Okay.
And I'm curious about how you see the overall state of maybe manufacturing and maybe I'll say North America, and we're supposed to be a developed country versus other parts of the world. Would you say that we've captured most of the opportunities around process heat and being as efficient as possible, or there's still a lot of gains to be made, not only it sounds like on a cost savings but also for the environment as well?
Yeah, so we definitely, I would say we're in our infancy, to be honest.
Okay.
A lot of the low-hanging fruit things have been done. The low-cost, no-cost stuff. And it's wonderful. That's the first stuff you should do. But now we're getting to the point where if, the U.S. or North America more generally, and Europe is kind of leading the way in a lot of this. But, even they would say probably at the beginning / middle, if we want to truly reduce our carbon emissions, we have to start tackling kind of the larger projects like we're talking about, whether it be electrifying a boiler, whether it be solar thermal, where it's, where things make financial sense. But there are a lot of things that make financial sense. Heat pumps, energy recovery systems that actually make financial sense right now that we can do that can significantly reduce CO2. So I guess I don't know if I'm answering your question directly, but I think we're kind of at the infancy. There's a lot of things that need to be done, and there's a lot of progress that I think, I'm sure we didn't talk about it beforehand, but the new Inflation Reduction Act and the infrastructure bill, they're allocating billions of dollars to decarbonization. So we're actually, I've been telling all of my customers this, like, we are at the literal perfect time to do these projects. With all the money that's coming in, specifically focused on industrial manufacturing decarbonization, like, this is the time to do it. And so I think if we have the same conversation 5-10 years from now, hopefully I tell you we're right in the middle of doing it. And that we've made huge strides and that CO2 has gone down by X%. because I think CO2 from the industrial manufacturing side is 20 or 30% of all the CO2 emissions in the US. And something I always talk about is that, transportation is a huge part of decarbonization, and I would never minimize it, but there are millions upon millions of vehicles out there, right? For the companies emitting CO2, there's far less of them. There's not millions and millions and millions of large industrial manufacturers in the US. There's, some number of thousands of them. And so it's more of it's like a more concentrated target market.
Yes, I get it. It's fewer, but each one is perhaps a larger emitter than, in this example, like a car or truck. But at the same time, even though it's fewer, it does take a lot of capital. So, as you mentioned, there's a lot of incentives being released into the market to help with that cost and bring it down. Rick, if people are interested in learning more, what are some resources that they can go to?
Yeah. So, of course, I want you to visit our website, but short of a sales pitch here, the EPA has a lot of really good resources. A lot of times if you Google the different, business models, you Google, EPA is fantastic, and they have put out a number of really good things on that. Now, that's typically where, if we're looking for something, that's where we would go. That's a wonderful resource.
Good. And then what I understand too is that if you are in the position of where you're trying to decide which technology to use, what is the best what is best for your facility, that's also like where Skyven can help. So you don't have to know, I specifically need, this heat pump with these specifications. This is really where you can come in, and your team can come in and help and make those recommendations. Yeah.
And I think you're kind of hitting on something that part of the reason that our business model exists is the reality is most industrial manufacturers are focused on throughput, safety, and quality, right? Because they're trying to get their widgets out, whatever they are. And that's super important. And sustainability projects hopefully make the list somewhere, but it's really hard, and it's tough to find the resources for it. And so, Skyven does come in the idea that we're going to help identify the projects, but then we're going to provide resources as you go through that you need on the project management side, on the responsibility side. And that's, I was just talking to a customer the other day, they have one project manager for their entire, it's like a 40-acre plant, right? And so there's one person there that can do all their capital projects. And it's like, what's going to be prioritized? It's throughput, safety, and quality. And so hopefully, we're a resource there to help, both identify and then put them in.
Wonderful. Rick, thank you so much for being my guest today and sharing your knowledge and explaining a little bit about what is process heat, how it really impacts everything that we buy as consumers. It's used somehow, and it's a really interesting point of decarbonization. And I'm glad also that you made you mentioned the new Inflation Reduction Act and the infrastructure bill, because that's, we need to make sure the funding's there. A lot of people want to do this stuff. It's just, where do we get the money to pay for it? So it's good to thank you for connecting all those dots.
Yeah, no, thank you so much for having me on. I really appreciate it.
Thanks.